So thank you for the opportunity to submit this proposal or the submission for the Steel Awards. We are presenting the Club Med, specifically the village, the building that's in screen here, the roof structures, the challenges, the design. We'll touch on that. And I'm joined by John van Wyk, who's the principal architect and founder of Craft of Architecture. They were the lead architects on the Club Med Resort as a whole. And yeah, just going to go through some of the initial briefs, the designs, the challenges with John and ourselves. I'm Will Woodiefield from Structured Projects. I was lead structural engineer on this project, and it's a great opportunity for us to just share what we had done on this project. So the project brief, just quickly, the client's Tinley Leisure. Architects, as I've mentioned, is Craft of Architecture, and the main contract on this specific building, the village, was Abbeydale KZN. So touching on the project brief, and I'll go over to yourself, John.
Yeah, if you can just a little bit about just the general concept, which is what we briefed you guys with. So in terms of the sort of call it the overriding concept of this whole project, one of the main things we looked at is how to respond to the climate and also respond to the site. And the principal way we did this was to use the roofs as a means of expression of the kind of natural forest canopies that we get in the area, to express the shading qualities and shelter from rain and that type of thing, which speaks to the climate as well. You know, this north coast of KZN, it's an all year round good weather. But when it rains, you can still be outside. So we're looking for our roof brief, or our roof concept is really the concept of the whole resort. It's just to have these large overhanging, very simple, clean roofs, which also with the expression of the horizontal expression also ties them into the landscape a lot better. And then to have these roofs floating, so you really feel like you're just moving around through these spaces with these big floating elements that are giving you shelter from rain and sun.
Thanks, John. So,
sorry, one other thing we also had to, which was a little bit of a challenge, is because the site is quite dense. As you know, we've got 430 rooms, and we're trying to get as many of them to get sea views. I think we ended up with about 70% of those rooms with sea views.
Sure.
The roof, we needed to keep the roof profiles very slender.
Yeah.
So although we've gone with hip roofs, which is also quite a fairly traditional roof in KZN, because of its easy shading qualities and easy to get big overhangs. So the roofs were hipped, but we wanted to keep them as slender as possible in terms of their ridge line, to try and preserve as much views as we could from the back unit.
And from an engineering point of view, this was a rare opportunity to do something spectacular. We often start out with something bold and ambitious, and then as the project progresses, you sort of narrow it down to something more confined and less bold. And I think this project really showcases that great combination of something spectacular where there was a budget, intent, and just a big collaborative effort to make this vision a reality. So touching on the material justification, I think it was although a lot of materials had been considered, it kind of leaned itself towards structural steel as the primary use to achieving this goal. One, because I think the depth to weight ratio is ideal in terms of achieving those thin profiled roofs, the large spans, the cantilevers, the flexibility that it provides for feature aspects like those tree columns, John, that I think was something that we had never done before, and it's certainly a nice challenge for us.
Yeah, we thought we'd throw in a few feature columns that are very stylized kind of reference to trees in terms of just taking the concept of these floating canopies and one step further.
Yeah. So there was a combination of concrete and timber throughout the resort, but for the roofs, we just felt that steel's the only viable material really that would achieve this design, and I think it worked out pretty close to the initial design intent. The one sort of aspect of the village roof that we're going to focus on quite a lot in the submission is the entrance canopy. Certainly quite a remarkable structure in itself. And John, if you could just maybe again bring us back to the initial brief, the whole experience of.
Yeah, so I think it's the entrance canopy, but it's also the roof that floats over the entire reception area. So that there's a big reception area which you see behind between those two stone walls that runs through. So you really do we've really the guys have managed to achieve this effect of this. It's this massive, elegant floating canopy that you literally walking under. You don't feel like you're walking through anything. You walk under this canopy, it's giving you shade and shelter, and you walk through the glass entrance lobby and look straight out to sea without feeling. It just feels very light when you're in there.
Yeah,
and moving through. And then one of the other things, just looking at this image, was being able to achieve that cantilever just helped us a lot with dealing with turning circles of buses and things like that need to drop off. It eliminated any risk of structural damage if a guy's slightly offline, and it gives a lot more freedom to design the outside Port Cochere area.
Yeah, and I think it's just for context, this is kind of the first experience that the guest would have entering the resort. This is where they get offloaded with the buses. So it demanded something remarkable and something wow, and certainly quite an engineering and architectural challenge, but something that we're quite proud of and that we want to highlight in this submission in terms of achieving that intent that was set out through using steel. So project overview, just the type of structure, the timelines, and the sector that we're submitting this submission in. A bit of an overview, won't go into all the detail, but I think it's that quote that I put there sort of summarizes it quite well in the overall submission. Is it's only once in a generation that a project arrives where the ambition, the budget, and the brilliance align. And Club Med's village roof was that project, and the team refused to waste it. And it's certainly something that we're very proud of, and we've all learned a lot through this whole process, and can take that and explore that on other projects. So again, just touching on the use of structural steel, how we enabled this 11-meter cantilever roof was thin profiles, a combination of I-beams, of lip channels, of equal angle legs, and pre-cambers, and all integrated with the architectural finishes, the other consultants' requirements in terms of HVAC, in terms of lighting, and bearing in mind that it needed to perform in the harsh conditions that it will be exposed to in the North Coast with the wind, the rain, and still maintain its structural integrity. Also touching on the site, as John mentioned, it's a very condensed site, so there were a few challenges in terms of logistics on the site, access, laydown areas, maneuverability, all of that was challenges that we had to consider in the ultimate design. Just on the project overview, then, why steel was selected. I think steel was, as we say there, not merely the preferred material, it was the only material capable of delivering the full architectural and functional intent, where concrete and timber would be useful in other applications. In this case, to achieve that design intent, the brief that John had explained, these open canopies, these large spans, steel was really the only material that would achieve that. Timber would just not give us that span to depth ratio that was needed. And I think steel's formability was also equally critical. It's agile, it's flexible, and it's easy to assemble if designed rightly, which I believe we got right in this case with easy assemblies and erection processes. The lightweight superstructure also simultaneously reduced the foundations. So there's a saving in that regard as well. It's not just the roofs that we're looking at, but the overall design and how it performs from a commercial perspective, as well as from a life cycle and efficiency perspective. The engineering solution to that 11-meter cantilever canopy that we've already touched on, I think just exemplifies the creative application of classical. So just how we went about the structural design to enable these large spans, these thin profiles, the hip roofs, and ensuring that it all speaks to the other consultants' requirements within that roof profile. I'll go into a bit more of the technical details later on. I think lastly, just the sustainability considerations. There was a big emphasis on the project as a whole in terms of sustainability, in terms of environmental considerations, recycle materials being used. This project being so close to the ocean obviously had to be extremely sensitive to the environment and especially during construction. And again, all of our design considerations took this into account to ensure that nothing that we had presented on a design paper would compromise the environment or any sustainability considerations. So most of the steel members were fabricated off-site, hot dip galvanized, and easy assemblies made it simple for the contractor to erect these structures without delay. The project's significance, I think it's well broadcast in the media lately, and perhaps the last few years even. Our first Club Med in South Africa is really a landmark development in South African context. And with that brings a lot of local employment, upskilling, and a lot of visitors we hope that will enjoy this facility and get to experience these big open spaces and the architecture, the engineering, and the whole resort experience. Then on the structural steelwork, just again, the cost of the steelwork, the tonnage speaks to the entire roof, not just the entrance canopy. That's the whole village roof. And the profiles we've used was a combination of universal beams, lip channels, equal leg angles, and flat plates. The structural framing, the design was done by ourselves. Structured steelwork contractor was Ogilvy Engineering, a local steel fabricator, and the steel detailers were PSM. Just touching quickly on the structural framing, like I've mentioned, the members that we've used, and it was a combination of lightweight but yet durable for the conditions that it was going to be exposed to, as well as the internal fit out. There's a big emphasis with Club Med on the end user experience. So there's a lot of decorative features inside that often gets suspended from the roof structure. The look and feel, the noise, the insulation, the heat, all of that had to be considered in the design of the steel roof. And again, steel just was the only viable option to fulfill all of these demands that the end user sort of placed on it, not just the design as a structural element in isolation. Our columns were mostly reinforced concrete columns that we fixed the steel to, and our overall stability strategy comprised of a combination of adequate own weight bracing and secure fixings and ensuring that the roof stays down when the wind blows but doesn't sag under its own weight. So all of that had been considered. Most notable technically, again, just that entrance canopy, I think, is by far the most notable technical challenge on this roof. And there, I think it was a combination again of ensuring that we only have the own weight of the materials, the steel, the ceiling boards, the insulation where we needed it, so that it doesn't deflect under their own weight, but also having sufficient weight so that it doesn't blow off when we experience these high winds that we get on the north coast. So a lot of consideration in terms of the constructability, the assembly, the ultimate performance of the material in the harsh conditions, and yet maintaining that thin profile, sleek looking roof, but being able to drain it adequately, so that there's no maintenance and other issues that the operator would experience. In terms of the connections, we used a combination of Procon, Revit and Tekla to do clash detection, to size the connections and check that it all worked out per our design intent. And during construction, we considered how these large trusses and girders would be assembled on site safely, but also efficiently. So we use a combination of bracing and pre-canvas to ensure that the roof would be erected safely and without delay. Just on the software that we used, again, Procon, Frame, Revit, the architects also have software that's integratable with. We use BIM across the project with all the various consultants, and I think, John, it was a really good experience of integrating our engineering software with architectural software, with some of the other consultant software, and ensuring that the final product that goes to site is checked, coordinated. So yeah, in that regard, I think it was certainly the right approach. We didn't experience any clashes, so to speak, on any of these roofs. It was very well coordinated before it even went to the production yards. So BIM integration was hugely beneficial from a design and fabrication perspective, but also I think for the client, it gave them options to look at before the call was made, what it would look like, what it would feel like, and even what it would cost before it went to the yard. Just again, touching on clashes and design changes, we'd gotten architects' initial renders, the designer developed throughout the design stages, and eventually I think we landed with something that very closely resembles the design intent, that brief, using the software that we have at our disposal these days. I can't speak for many years ago, but I'm sure it wasn't this easy to do sort of intricate and complex designs and coordination and clash detection without the software that we have today. So this was, again, hugely beneficial in executing the design. On the fabrication side, just briefly, the steel contractor, local-based fabricator, as I've mentioned, and these guys really also just came to the party in terms of meeting the design requirements. There's such an emphasis on the visual aspect of this roof that it had to be absolutely sort of perfect, really. We couldn't allow any obvious deformations, any ugly connections. So it was trying to find that nice blend between a structural performing column roof structure, but also meeting the requirements where it's that the connections are hidden, the welds are seamless, the rolled members, those circular hollow sections that form the tree columns are just seamless, slender, skinny, but yet functional and robust to meet that intent. On the technical excellence and quality control, again, marrying simplicity with the robustness was the big challenge here. We wanted something light, something efficient, but it had to be able to withstand these loads. And we inspected ourselves, and the architects had inspected the yards before and during fabrication, just to ensure that the desired finish and intent was being produced on the yard, so that it avoided any sort of comebacks on site. We wanted to avoid any site welding. So most of the welds in fact were done at the yard, and hardly ever was there the need for a site weld, which would compromise the galvanizing and the aesthetics. The connection strategy was a combination of bolted and welded connections. Bolted connections where it enhanced the erection and the assembly of the structures, but welded where we felt that bolted connections would be ugly and unsightly, or where we needed it for enhanced performance. So a nice blend of bolted and welded connections to ultimately give us the design as intended. In terms of the erection, construction, and installation, some of the feedback that we'd gotten from Abbeydale, the contractor, was really focused around the access challenge. There were 7 packages. The whole resort was divided in seven distinct packages, and which meant that there were 7 contractors working alongside each other on a very dense and high density site with limited maneuverability. So a lot of emphasis was placed on the delivery design, restrictive turning areas, the fabrication alignment, so that only what was really necessary would be delivered to site, and the continuous erection flows to ensure that the roofs would be erected on time and to meet the required spec. So there were no space really available for heavy cranes. A lot of it was erected by using mobile cranes, spider cranes that we had checked that would be able to go onto the slabs from a loading point of view, and a bit of a manual lifting system was used where necessary to erect the steel roofs and all of this steel aspects. In terms of stakeholder coordination, again, just a lot of emphasis by the whole project team, the project managers, the contractors had met routinely on a weekly basis, sometimes even on a daily basis, to ensure that deliveries were allocated strictly in defined dates and defined areas. This allowed the seamless sort of operation of each of the contractors, and certainly touched on the safety aspect on the site for everyone involved. There was a lot of collaborative planning done to ensure that deliveries were done on time, cars weren't waiting for materials and being delayed on site, so that everything could run smoothly, which really worked out well. And then just on terms of changes and quality assurance, there weren't any sort of late design changes really that I recall. Certainly not in terms of the architecture and structural integration. A lot of this was really well planned, designed, coordinated, and checked before it went to site. So there were hardly any changes necessary on site, especially with respect to the structural steel. As I've mentioned, we wanted to avoid on-site welding and modifications in as far as possible, and fortunately there weren't any of that came across. And this just touched on the uncompromised quality. If we ensured that the design was checked and coordinated and worked, we gave that steel structure the best chance of performing as it's intended with the lifespan that it's needed in these harsh conditions, and that no modifications were needed. Some of the challenges and solutions, again, that entrance canopy, I think by far was the biggest challenge from a structural steel design perspective. The geometry, the shape, the size just meant that we really had to apply ourselves to find a solution that could meet that design, which at the end we did quite well, but it required a lot of sort of iterative processes to ensure that it's checked, double checked and triple checked, member sizing, the deflections, the load combinations, the assumptions in terms of the loading during construction, and afterwards with the various materials that's used. And the way we did this was by a combination of trusses and girders, and utilizing that full lobby length to really create a nice backspan, where we had 2 main girder trusses running along the length of the lobby and to the edges of the roof, and then specific strategically placed trusses that run perpendicular to the girder truss to pick up these large cantilevers, the gutters, the roof, and the purlins. So the girder trusses were strategically installed near the tip of the cantilever, which acted as a massive load-sharing mechanism, which distributed the loads quite nicely along that cantilever, so that you wouldn't have any sort of differential settlement or deflection at the tips, and it behaves as a single rigid unit under the varied wind load. So it was really finding that sweet spot in the member sizing so that it would be able to withstand the permanent imposed dead loads, but also the wind uplift that it would be subject to. Some creative application of the engineering principles, just again, like I've mentioned, the tie back and counterweight principles, non-traditional lateral bracing. We had bracing on the bottom and the top because it had all to fit nicely within the thin profile. And the load sharing and redundancy was by combining cantilever mechanics with a continuous load sharing grid, that tip girder truss that I just mentioned. The design ensures that high localized wind pressures or dead loads are immediately shared to adjacent members. So I think overall it was really a simple design to a very complex structure, and it certainly performed really well. The benefits of steel in this application, I think we've already touched on, is just the strength to weight ratio, the depth to weight ratio. I think steel just outperforms any other material that we could locally source to perform this function. It had a hugely beneficial impact on reduced foundation loads, minimal supporting columns, and achieving that free-flowing open area look with some nice feature columns, feature roof elements across the resort. Then the hip roof, John's also touched on that, but yeah, again, just all of these aspects were considered during the design, ensuring that it doesn't just perform as a structural element, but really performs well as a architectural feature, as a means of draining the roofs when we do get these heavy rainfalls, and having it nice, slender, skinny, thin profile so that the views from the hotel rooms are unobstructed. Benefits of steel, again, just durability, material efficiency, future adaptability, and that optimal balance. I think all of that speaks to the way that we considered steel as opposed to other materials. And then quality assurance, sustainability, and efficiency, just touching on sort of our paint spec and requirements, the relevant standards and codes and compliance requirements that we had followed during our design. We wanted this to be a low maintenance, high performance steel structure that required no comebacks later on. Again, QA/QC system and application, there was a lot of emphasis on inspections prior, during, and after construction, and these were the QA/Q systems that we had considered. Sustainability and efficiency, the hot dip galvanized, it eliminates multiple primer coats. We've got a long lifespan. Structural steel is obviously recyclable, and everything was done in the yards before it was erected. So just to control that factory environment away from the site, reduce any environmental impact that it might have on site, and ensure that it performs the way it should. And then I think just lastly, we could probably have 10 or 20 slides of highlighting what we're proud of. I think as a project team, not just as engineers, as KZN residents, this is really a project that we all are very proud of. If we look at the job creation, the direct local employment, local integration, operational commitment, a lot of direct and indirect jobs will be created through this development. The bigger picture is just how it contributes to the combating the high unemployment rate that we experience in KZN, but as a country, and then just the Club Med brand coming to our coast, bringing with it that whole experience that we can be immensely proud of. And then the project team collaboration and success, I think from contractor to consultant to client, everyone involved really put in a huge effort, a lot of time and energy in ensuring that the product is something that we can ultimately be proud of. Alexia, the engineer that's worked under me on this project, summed it up quite nicely, where she says, what began as a daunting structural challenge evolved into one of the most rewarding aspects of the project. By trusting the process, leveraging the expertise of our mentors, and collaborating as a team, we delivered an 11-meter cantilever steel roof that is both architecturally stunning and structurally audacious, yet entirely sound. And I think that just sums it up so nicely, where ambition and intent meet. Tabang Letswalo, also from our team, said the North Coast and KZN is rapidly developing. I'm happy to have played my part in the economic growth in this part of the country. From engineering concepts to occupation sign-off, it's not just the engineering details that made it work, it's the continuous engagement with different stakeholders that helped build the biggest leisure development in South Africa since Sun City. And Club Med wasn't just another project on my list, it was my opportunity to contribute to the ever-growing North Coast. And then lastly, just that quote that I started off with is, this really provided us with a once-in-a-lifetime opportunity to do something bold, something ambitious, fully supported by the project team and the client with the necessary budget and the brilliance that aligned with that to achieve something that we are really proud of. So yeah, that's it from our side. Thank you, Liesel, and thank you again, John, for joining in this discussion.